Hello everyone and welcome to this lecture on Jenkins. We're going to do a quick overview of Jenkins. So Jenkins is an open source automation server which is used to automate a variety of tasks related to a CI/CD pipeline in a DevOps workflow. So if you don't already know what a CI/CD pipeline, please watch my lecture on DevOps specifically related to CI/CD. So in a CI/CD pipeline, you are going to do a variety of tasks, and the main tasks are basically building your source code, testing your source code, and deploying your source code deploying the build artifacts from your source code onto a production server. Okay, and so that is all done by Jenkins. Now Jenkins is a server-based application, so Jenkins needs to run on a web server. The most popular web server that is used for Jenkins is Tomcat. There are other options as well, but Tomcat is probably the most widely used one. Tomcat is basically a servlet container. It conforms to the J2EE specification, okay, Java Enterprise Edition. Okay, so in order for you to run Jenkins, you kind of need to have Java installed. And Jenkins, of course, is written in the Java programming language. And Jenkins, like Java, because Jenkins is written in Java, Java is basically a cross-platform language. So you can run Jenkins on Windows, Linux, Mac OS. You can even run Jenkins inside a Docker container as well. So if you don't know what Docker is, please watch my video on Docker. Alright, so here is a CI/CD pipeline. So this is a quick revision of what we have already done in my lecture on DevOps. So basically you have a committing of change during the CI stage of the CI/CD pipeline that will trigger a build process. So there will be a build that will be done. Okay, so this is kind of managed by Jenkins. Then the build process happens. Then there is a notification of the build outcome. Build is basically compilation. So whether the build was successful or not, if the build is successful, you run a whole bunch of tests on the compiled source code, okay, which is what we call your build artifacts. So if there are no errors, then there's a notification of test outcome. You then send it on to the staging environments where you run further tests as well on it. And then if all the tests pass, you finally push your build artifacts to your production server. Okay, so all of these are going to be, every stage here in the CI/CD pipeline can be managed through Jenkins. Okay, so Jenkins, although a lot of times we call Jenkins as a CI server, but technically Jenkins can handle every single aspect of the CI/CD pipeline. Okay, although like I said, the focus is primarily on CI. So you are going to see that a lot of times we're going to talk about integration of Jenkins with VCS functionality such as Git, GitHub, Bitbucket, and so on. Okay. Now Jenkins uses a plug-in architecture, which means that its functionality is primarily achieved through the installation of plugins, and these plugins are going to perform the various CI/CD tasks. So all these tasks here that you see in this pipeline, they are going to be performed by individual plugins, okay? And there is a large ecosystem of plugins available for Jenkins, and this is what gives Jenkins its power, right? Jenkins has over more than 1,000 plugins available that can make it work, or they can help it work with every single DevOps tools that you have heard of, and many that you probably have never heard of before. Okay, so that's what makes it so nice, what makes it so extensible. Okay, and a pipeline is basically a suite of plugins which you combine together to support the implementation of a CI/CD pipeline in Jenkins, right? So every single one of these tasks here will be performed by a specific plugin, and all these plugins, when you combine them together, we call them a pipeline. That's the term we use in Jenkins. Right, so when you install Jenkins, you are probably going to see a whole bunch of plugins like this, and you can see there are many plugins. So when you click on the available button here in Jenkins, you can see there are literally hundreds, if not thousands, of plugins that can do every single thing. From building, testing, deployment, everything. Okay, build every single aspect of building, and then you have many kinds of build tools, many kinds of deployment tools, and so on. Right, so all of them are available as plugins, and they're all free. They are developed by the open source community. You can access them, and you can install them into your main Jenkins engine. Alright, so you can see this is how the plugin pipeline works. When you run a pipeline or a job in Jenkins, you're going to see it's going to move through several phases, and all these phases basically correspond to your CI/CD pipeline, right? Your CI/CD pipeline is going to have all these things, and you're going to see, okay, well, the first phase here, this is a build plugin that does the building. There's a compilation process. This is how long it takes. Then there's the testing part, and this is testing for it's an integration test. This is a functional test. This is a load test. It's also a security test. So you can see there are a whole bunch of tests here, as we already mentioned in the previous lecture on DevOps. Testing is very important, automated testing, and all these tests are going to run automatically, right? So this whole pipeline is all fully automated. It's just going to run automatically. Okay, then finally you have approval phase where somebody will sign off, and then finally you deploy to your production environment. So you can see this is the flow of your pipeline in Jenkins, right? And the plugin for tools, there are plugins for every single tool in the DevOps lifecycle. So if you recall in my lecture on DevOps, I talked about the various phases of a DevOps lifecycle and all the various tools and the tool chain that you need to use in order to implement DevOps successfully. So with Jenkins, Jenkins is a CI server, CI/CD server. Okay, it really has plugins for every single conceivable tool in DevOps. So Jenkins can work with Ansible, Puppet Chef. These are all IAC and CM tools. It can work with monitoring tools like Nagios, Splunk, Sensu, New Relic. Okay, can work with build tools like Maven, Gradle, and testing tools, JUnit, Selenium, and of course it can work with Git, and also of course other project management software, Jira, Slack, and so on. Okay, so you can basically work with all the kinds of tools you have in your DevOps lifecycle. Excuse me. So Jenkins is typically run in a distributed manner, which means that you're going to have many pipelines executing concurrently. So this is a pipeline, and you're going to have many pipelines running concurrently, and so therefore if you have many pipelines running concurrently, the builds can take a long time to execute if you are running all of them on a single machine. So if you install Jenkins on one single machine and you are running many pipelines, so in a large company you may be running many pipelines, maybe hundreds of pipelines at the same time, and so you're going to be running hundreds of builds at the same time. So if you're running a build of a complex software project, the compilation may be very complicated because you may need to download a whole bunch of library dependencies in order to complete the compilation. So that means the build will take a long time to execute, and so therefore we typically do not run Jenkins on a single machine. Okay, although in a lab session we'll probably just use a single machine most of the time, but typically in a real-life situation, we use a master-slave architecture to balance the build workload across multiple slaves. So in the master-slave architecture, you have the master node, which is where Jenkins is installed. This holds all the key configuration metadata, okay? And the Jenkins master will receive a build trigger. So a build trigger is basically something that kicks off the build process. So for example, if you recall the DevOps CI/CD pipeline, the first thing that developers will do is they'll commit their latest code changes to a central repository, for example GitHub or Bitbucket. So the moment a commit is done, it will trigger a build signal, and then the Jenkins master will start a build. So what it will do is it will send off a bunch of job executions on agents that will manage the build process. Okay, so that's what the master will do, and after the build is completed, it will send notifications to the developers by email or using particular project management tools like Slack or Jira or so on. You send these messages whether there is a build success or build failure. Okay, and you also monitor the status of all the agents or slaves in the system to see whether they're still alive or online. All right, so that's the master. Then you have multiple slaves or agents. We call them either agents or slaves, and these are nodes that will execute the task in a job. So most of the time, the task we are interested in is builds. Builds because these are the ones that really take up a lot of time, okay? But of course, you can also be executing testing as well, maybe doing deployment and so on. So it depends on basically how you intend to use Jenkins, right? So here, if you are using it for build, Then the worker nodes typically will have a variety of operating system and build environments. So for example, like you might want to compile a Java source code, but you might want to compile it in Windows, you might want to compile it in Linux, and you might want to compile it against Java 8 or against Java 11 or against Java 17. So you might want to compile it against different versions of Java in different operating systems using different build tools. For example, maybe you want to use Maven, you want to use Gradle, you want to use Ant. Okay, all of these are Java build tools. So you may want to have different build environments, different variety of operating systems. This can all be accommodated on your worker nodes. Okay, now typically you are going to have master and slave, and so the slave or the agents will be the one that does the build. Okay, but if you, for a very simple situation where you just only have a master, you just have one single machine when you're running Jenkins, which will be the case, you know, if you are not really running a lot of builds, then the master will also work as an agent. So the master is essentially going to do all the builds. Okay, so agents, like I said, can be configured to be generic, which means you can run all the tasks, you can run all kinds of builds, or you can say that, for example, you might want to have certain operating systems on certain agents, so then you can only confine the builds to certain agents. Like, let's say you have a certain agent which you only have Java 8 installed, or you only have Python 2 installed on that agent. Okay, then basically when you want to compile applications for Java 8 or for Python 2, then you will only use those agents. So you can limit your build, run your builds to specific agents or to many agents in the system. Okay, so this is your Jenkins architecture. You have your master. Okay, your master has a whole bunch of plugins and then configurations, and then these are the jobs that are going to be run. And then there's a list of nodes or agents that's going to connect to. So you can have Linux nodes, or you can even have Windows nodes as well. And you can have also nodes or agents that are running in the cloud. Okay, so in the cloud, you'll probably use container technologies like Docker. You use Kubernetes to manage your Docker containers, or you might have AWS, ECS to manage them. Okay, so a variety of options available to you. You can connect to all these slaves or agents using SSH. SSH is the most common, but you can also use other protocols like JNLP. You can use the cloud API for, you know, Amazon or Google or Azure or whatever. So this is, of course, many options open to you in terms of what you want to use as your slave nodes. All right, so the Jenkins master node obviously is a Java program. The slave nodes are also all Java programs, and basically you have all these builds that you want to run. Most of the time are builds, okay, but you can also be other tasks as well, but most of the time you're going to be doing builds. Okay, so you have a build here that you want to execute, and then you send it off to the slave nodes. The slave nodes will have multiple executors, so each slave node is basically a JVM process which has multiple executors, and each executor can run one particular build. Okay, so you can have many builds running at the same time. Okay, and like I said just now, the way you're going to trigger a build process is one of the developers in the team is going to make a commit to either the main branch or to a feature branch in GitHub or in Bitbucket or any one of the cloud hosting repositories. And so when the commit is done to the feature branch or the main branch, that will trigger the CI process. The Jenkins server will pick up that there has been a commit, then it's immediately going to pull over the code base from GitHub, and then it's going to run the build process on all these different slaves. And you can see the slaves are all have different operating systems, right? One is Windows, one is Linux, one is Mac OS, and you can select which build you want to run on which slaves. Like for example, let's say you know that for a fact your production environment is only Linux, so you don't have to run the build on a Windows slave, you don't have to run the build on a Mac OS slave, you can just run it on a Linux slave because you know that your production environment is only going to be Linux. So there's an option for you on how you can control this, and once the build is finished, then you have a test report. Okay, so this is of course for build. Then this is the same thing as well for any other kind of task or activity that is going to be performed by Jenkins. All right, so that's a very quick overview of Jenkins architecture.